Hi friends, we are going to talk today about what happens when we take an inequality and we multiply or divide by a negative, because something very special happens. So to start out, we're just going to talk about positives. So line 1 says compare the numbers in line 1 using greater than and less than symbols. So by line 1, we're talking about all of the numbers here across. So let's go through and we'll do that. So we've got 8 and 2. So 8 is greater than 2. 7 is less than 10. Negative 4 is less than 1. And negative 5 is greater than negative 25. Okay? Now, number 2 says multiply or divide each set by a positive number and compare again. So this is what we're going to do. We're going to pick a number to multiply or divide each set by. So for this first one, we have 8 and 2, and we're going to divide them both by 2. Because we can. And when we do that, 8 divided by 2, that gives us 4, and 2 divided by 2, that gives us 1. And so now we're going to compare the 4 and the 1. Well, 4 is still greater than 1, so that held. Let's multiply this time. Let's multiply them both by 3. 8 times 3 is 24, and 2 times 3 is 6. Let's compare again. 24 is greater than 6. And then let's do 8 times 5 and 2 times 5. So notice that I'm multiplying and dividing by the same on both sides. I have to do that because I'm trying to maintain equivalency. So we're thinking about this the way we would when we solve. We're doing the same thing to both sides, or else it's going to mess everything up. Okay? So now I have 40, and 2 times 5 is 10. And look. Okay, so I want you to notice that all of these are the same, okay? That is important, and we're going to keep looking at a couple more and see what happens. Okay, so now we have 7 and 10. We can't really divide them by anything and get in a whole number, so we're not going to, but let's do 3 again. So we've got 21 and 30, and 21 is still less than 30. Okay, let's pick a different number. Let's multiply by 10. So I've got 70, and I've got 100. Okay, let's compare again. 70 is less than 100. Okay, let's multiply by 6. So we've got 42 and 60, and 42 is less than 60. And hey, look, all of these match. Okay, let's try some with some negative numbers. See what happens. I've kind of hinted all week that when we get to negative numbers, funky things start happening. So let's see if our funky things will start happening now. So let's take negative 4 and 1, and let's just start out real straightforward. We'll multiply by 2. We've got negative 8 here and 2 here. Negative 8 is less than 2. Okay, let's do 5. So negative 4 times 5 is negative 20. 1 times 5 is 5. Negative 20, less than 5. And let's multiply by 7. So negative 4 times 7 is negative 28. And over here we have 7. Negative 28 is less than 7. Okay, so when we've got one negative, it still holds. We've still got an entire row of less thans. So nothing changed. All right, let's try it when they're both negatives. Let's see what happens. All right, so let's multiply by 8. Ooh, that's going to give us a big number. That's okay. We can handle it. Okay. Negative 5 times 8 is negative 40. And negative 25 times 8 is, if you don't know that off the top of your head, that's okay. It's negative 200. And negative 40 is greater than negative 200. Still matches. Let's try division. We can divide with this one. Let's divide by 5 on both sides. Okay, so over here we'll get negative 1. Over here we'll get negative 5. Now let's compare. Negative 1 is greater than negative 5. Okay, let's try one more multiplication. Let's just multiply by 3. Negative 5 times 3 is negative 15. Negative 25 times 3 is negative 75. Let's compare. Negative 15 is greater than negative 75. We still have no change, even though we were working with negative numbers. So what do we notice? Well, when multiplying has a G, or dividing by, and what kind of numbers specifically were we multiplying and dividing by? We're multiplying and dividing by positive numbers. By positive numbers. And did anything really change? No, our inequality stays the same. The inequality stays the same. Okay, so let's highlight some important parts. So when we multiply or divide by positive numbers, it stays the same. Okay, so we're going to do the same thing again. I know that was kind of tedious, but it's really important that we pay attention to what's going to happen. And this time, we're going to multiply each set by, multiply or divide, by a negative number and see what happens. Okay, so let's start by comparing our first line. It's going to be the exact same. 8 greater than 2, 7 less than 10, negative 4 less than 1, negative 5 greater than negative 25. Same as up there. No change. Okay. Let's start doing some multiplication and division, this time by negative numbers. So let's multiply. Let's just start by multiplying by negative 1 and seeing what happens. Okay, so 8 times negative 1 is negative 8, and 2 times negative 1 is negative 2. Now let's compare. Negative 8 is less than negative 2. Okay, so now we have a change. Our inequality has flipped to the opposite direction after we multiplied by that negative 1. Let's try a different negative number. Let's multiply by negative 3. So 8 times negative 3 is negative 24. 2 times negative 3 is negative 6. When I compare, negative 24 is less than negative 6. So it flipped again. Well, maybe it's just with multiplication. Let's try it with division. If I divide both of these, you know what, I'm going to use fraction for division. If I divide both of these by -2, 8 divided by -2 is -4. 2 divided by -2 is -1. And when I compare, -4 is less than -1. So now we see, okay, I multiplied and divided by negative numbers, and it switched. My inequality flipped from a greater than symbol to a less than symbol. Well, maybe that's just with 8 and 2. Maybe that won't hold with other numbers. So we better try it. Let's try -1 again. So we've got -7 and -10. And -7 is greater than -10. We have a flip. Okay, let's keep trying. Let's multiply by -5. So that's -35 and -50. And -35 is greater than -50. Okay, what if I multiply by -10? Ooh, barely had enough room for that. Okay, so -70 and -100. Once again, it's greater than. So I have it flipping. All right, it's starting to seem like maybe this works all the time. Let's try a couple more. Now we have a negative. We're starting with a negative. Maybe it only works when we start with a positive. So we better check to make sure that this continues to work. Okay, let's multiply by -2. -4 times -2 is +8, and 1 times -2 is -2. 8 is greater than -2. Look, I have a flip. Let's try multiplying by, what haven't I done well? Let's do -8. Ooh, that was a tricky 8. There we go. Times -8. Okay, so we've got now here a +32 times -8. 32 is greater than -8. Okay, so we see that it's flipped. Let's now try it where we've got two negatives. We're pretty sure at this point, I hope, that we see a pattern here that holds, but we should make sure with one more case just to check. Let's multiply by -3. Multiply by -3. So -5 times -3 is a +15. And -25 times -3 is a +75. And 15 is less than 75. Okay. Let's do one more with dividing by a negative number. 5 divided by -5, and -25 divided by -5. So here I have 1, and here I have 5. And when I compare, 1 is less than 5. So, what are we noticing that happened here? Well, it looks like our pattern is that when we multiply or divide by a negative number, our inequality flips. It doesn't stay the same anymore. So let's write that down. When we multiply or divide by a negative number, the inequality flips or changes, whatever word makes more sense in your brain. So let's highlight the important parts. So we're multiplying or dividing by a negative number, and in this case, the inequality changes or switches or flips. Any word you want. Okay, so let's look over everything we've noticed so far. So in the first half, we were using positive numbers and everything stayed the same. So nothing changed. In the second half, we multiplied and divided by negative numbers, and then it flipped every single time, no matter what combination we were using or whether we're using multiplication or division. Okay, so this is an important piece to keep in mind because we're going to apply this later on to doing some of our solving inequalities when we have negatives.